if there is an issue with I had a customer not long ago in Alaska that had a coil go bad. Now, he's in Alaska, so he went to his local dealership. He had a L96 or an LY6, I don't remember, and they diagnosed it as a bad coil. They replaced the coil, and he was back on the road. Now, that's not going to be so easy if you have a hybrid, a GM engine inside of a Chrysler operating system, or let's say you have a CAN interface that's putting out data that they don't understand. Most of these mechanics just won't deal with it. They're not going to put their time and effort into trying to backwards engineer or whatever you did. So these are all concerns that we have because we've done literally hundreds of swaps, and we want to make sure that these swaps can be supported at your local level. We want to make sure that your local dealer or independent can pull up a wiring diagram on your vehicle and the wiring color and the troubleshooting chart is going to match. That's not going to happen with an aftermarket harness, especially with harnesses that don't run or don't follow the rules for proper power distribution, ground distribution, redundancies. For instance, in most LS engines, they're divided by two banks, bank 1 and bank 2. Coils, injectors, O2 sensors are divided by bank 1 and bank 2. These engines are essentially 8 single-cylinder engines, and I know that some people might comment on this. It is not independent single-cylinder engines, but for the purposes of fuel delivery, spark control, each cylinder is controlled independently. The timing on each cylinder can be changed by the computer. The knock detection on each cylinder can be separated from the others. The fuel delivery obviously can be changed for each individual cylinder. The failure modes and diagnostics, meaning if you have a cylinder that loses compression or a coil goes bad, the computer can shut off that injector, shut the fuel off so that you're not in a gross polluting mode, and you can drive it home. Now, that's not going to happen with a aftermarket hot rod style harness where you don't have proper power distribution. If you have 2, 3, 4 power distribution wires and you don't separate the injectors and the coils and the O2 sensors properly, the system cannot sense and then react to these failure modes and get you home. If you don't have proper ground distribution, meaning ground paths are very critical in modern operating systems because ground is where everything returns, and there's what's called low reference. Low reference is ground supplied by the engine computer. And why do we want the engine computer to supply ground to a sensor? Well, a lot of these sensors run 0 to 5 volts. The O2 sensors in general, the narrow bands run 0 to 1 volt. That's 1,000 millivolts. And these are very sensitive circuits. So if you had a 1/10 of a volt drop across your ground circuit, then you're going to be off 10% on an O2 sensor signal. So basically, by having the computer supply the low reference, it's internally comparing that low reference to the signal input and has a much more accurate signal to react to. So that's why it's so critical to have proper ground distribution. The transmission is grounded, and it's electronically controlled transmission, and it has its own ground. The MAF sensor, the MAF sensor in GM operating systems, as you know, is extremely critical. It's the main airflow sensor. We don't revert to speed density unless we have to off the MAP or the intake manifold vacuum, which Chrysler does. So the MAF having proper ground is critical. It has its own ground path. Then you have, of course, the ECU, and there's a main ground going into the engine computer. That has its own ground. And there's a lot more. So we run about 7 ground distribution wires to make sure each of these inputs and outputs, and especially when it comes to something like a throttle body. Throttle bodies have electric motors inside of them, so they're not just sensors, they're actually an output, and they need to have proper power and ground for the throttle body to work properly. Otherwise, you're going to have reduced power issues. So we stick with that. GM spent who knows how much time and money getting that right, and in the early Gen 4 LS's, there were a lot of reduced power modes, and GM did beef up their ground distribution paths. I remember in the early days going with 4 ground distribution paths and having reduced power issues. So things have come a long way, and we have essentially done what GM does. If you were to look at an E-rod harness, let's say, that harness was not designed to put in a US EPA production vehicle. That harness was designed for a pre-OBD2 vehicle that does not have to pass the stringent monitoring of onboard diagnostics. So we really can't compare that to what we do. We need to make sure that we are up to the latest tier emissions in the OBD2 enhanced CAN or controller area network vehicles, and that's what we do with these harnesses. And it's hard to convey from an engineering standpoint how much is involved there. It's easy to build a simple harness. It's easy to run an aftermarket hot rod tune, and if that's what you're after for a buggy, it works great. But if you want full OE protection, safety, failure modes, emissions compliance, there's just no other way around it. GM has spent millions, and so has Chrysler, on making these vehicles perform and still meet government regulations. And when they have a vehicle certified by the US EPA, all this comes into consideration. The hardware, the software, the calibrations. And when we go for an emissions test, and I had 2 vehicles certified last week, one Gen 5 and one Gen 4, they're looking at block numbers. They're looking, in California now, a dealer has to verify the calibration, the software identification, to make sure it's a CARB compliant calibration. So if you're looking at that level of functionality, and we have since the beginning, being an emissions inspector and diagnostic technician of basically 20 years, has taught me a lot how to work with the system. And there's no reason to work against it or try to get around it, because the reality is it's getting tougher. I've been dealing with Nevada, Arizona, Utah, Colorado. We just had one certified in Colorado. And because I have an emissions background, and because starting in 2008, my goal from the beginning was to keep these Jeeps compliant. A lot of guys don't understand. They look at the kit and they say, well, why do you have all these extra wires? There's a reason for these wires. You need to trust me on that. If we could eliminate them, we would. And we can eliminate them, but you would lose something somewhere else. So we're not doing that to increase costs and increase the installation time. We're doing that because there is a legitimate reason. And it's easy to make something simpler, I want to say. It's hard to make it simple and function the way as intended. And that's really the key here. We have simplified our install to a point that it's pretty much on par with anything else out there, but at the same time, we maintain full emissions compliance, full functionality, safety modes, redundancies. You're out in the middle of nowhere with your wife in Death Valley, you have an injector go bad and short out, you have one ground distribution path, bam, you're done. You're not going anywhere. With our setup with multiple, and I will say I had a customer recently in Texas where a ground was not hooked up and the vehicle still ran. He was driving the vehicle around. It had some issues, but it was actually driving with the main ground to the computer not hooked up. And that just shows you how important these redundancies can be. The difference between you getting home and you being stuck out in the middle of nowhere. So all this is going through what we do. Having 8 years of experience with the JK, 30 years experience in engine swap technology, and working with the rules, working with the laws, not just trying to build something that works, but something that works within the system that's coming up and is here already, is the hard part. And that's what we do. And if you were to call us and say, I've got a PO 101, 102, and I can't pass an emissions test, or I'm having an issue, we're going to tell you exactly what that is. And whatever that code is, that code can be run and troubleshot just like a factory vehicle. P101 is math for rationality, P102 is math circuit. So I will tell you exactly where to go to check this out. Now, if you're working with a hybrid system, that code's going to be really difficult to work with. And I've actually done that. I've been working with some of these hybrid systems. If you were to work with a reduced circuit harness, you're not working with OE ground distribution and power distribution. I can tell you the math sensor on most of these Gen 4s, what terminal they go to on the fuse box. So it's a simple matter of checking the power there. I can tell you exactly where the ground goes on the block for a math sensor and a GM, so you can check that block. Now, if you've got one wire splitting off into 7 directions to support 7 different ground paths, where are you going to find that wire? Well, you're going to have to go back to the harness maker and say, where does this ground go? How do I diagnose this? we don't want to go there. We want to make sure that you have this full, not only our support, but the support of the manufacturer, so that if something does go wrong or something does need to be fixed or corrected, you can diagnose it the same way you would a factory vehicle. That's what we do. That's what we're going to continue to do. And whether it is this LS3 in this two-door, which is a lot of horsepower, 450 horsepower, in a two-door with 35s. I think this is 35s. It might be 37s. It's a lot of fun. Or a 5.3 iron engine with 300 horsepower that just gets you where you want to go in style. You're going to have that full factory OE level functionality and support. And I can't stress that enough. I don't know of any other kit or manufacturer out there that does this to the level we do it. AEV, maybe. The problem with the AEV swaps, and it may not be so much anymore, is they were using hack calibrations. While they were using OE level hardware and wiring, they were not supporting the OE level calibrations, so there were problems with monitors, mode 6 data, etc. I know they're trying to work around that, and I know that they're trying to work with it. But as far as we go, sticking true to the GM's philosophy for software, calibrations, hardware, wiring, we've done that not because it's easy, because it isn't. It's hard. We've done that to get the advantages, the reliability, and the safety that comes along with it. So I can be out here in the middle of nowhere with my family, and I have been, and I know that this system is going to monitor itself, and I know that this system, if there is a failure, the odds of me getting back are much higher than if I had something that was less than acceptable.